is 3-5. We're going to be solving rational equations. So we're going to just get right into it. Like I said, there is a lot to learn, and really the best thing with this is letting you guys just practice a lot of it and making sure you're understanding it. So we're going to be doing lots of practice today. You will have an online assignment for this. So what we get done in class on that paper is what's required for you to get done. Okay, so to solve a rational equation, the first thing we're going to do is get the least common denominator. So remember when we were adding and subtracting rationals, we had to get a least common denominator. The reason we like to get the least common denominator is there's a lot less simplification. That's going to be also true for solving. So the nice thing is, once you get a common denominator on these, think about it. If you are solving for something and then in the bottom you're going to have the same thing, are we just finding the x that's going to make the statements true? So now that we've got a common denominator, won't those bottoms definitely be true? Well, they'll definitely be equal. So once you get a common denominator, you can just literally focus on the numerator, focus on the top, and solve it. You can ignore the bottom once you have a common denominator and just solve the top. Because once you find that x value, of course, it's going to make the bottom equal. Because they're all the same. Does that make sense, everybody? Okay, awesome. So it's actually pretty easy because once you get it down, you're going to be solving something either linear or quadratic. Now, one thing to note is we're going to be taking and manipulating these equations, manipulating them, changing them by fancy ones. Does that make sense? But when you do that, it can introduce extraneous solutions, which extraneous solutions are just solutions that are introduced in all the manipulations. So it might be a solution of the new polynomial that you just fixed, but it won't be a true solution to the original. So how we can tell if it's extraneous or not is whenever we get a solution, we go plug it back in and check it to see if it's truly a solution of the original polynomial. Does that make sense? So then if you do that and you check the answer and it's not a true statement, then you throw that answer out. It's extraneous. And that's because you've done and manipulated all this and made it all of a sudden quadratic, but you've done it properly, but yet that quadratic solution wasn't a solution to the original. Does that make sense, everybody? So we'll just check for extraneous solutions. You have to check. On the test, you're going to have extraneous solutions. Today, you'll have some extraneous solutions. All right, so here we go. Let's just start practicing. That's all you have to know. Get a common denominator, solve for the top. So, everybody, I think some of you still struggle with figuring out least common denominator. So, we have a 3 in this denominator. We have a 2 in this, so we have got to multiply by 3 and 2, and then this 10 is a 1, correct? So, our least common denominator is 6, so we're going to make all of our denominators 6 one way or another. So, when we multiply by 2 over 2, we're going to multiply by 3 over 3, and over here we need the denominator to be 6, so when we multiply by 6 over 6. Okay, now we have 2x over 6 plus 3x over 6 is equal to 60 over 6. Now, do you see how all the denominators are the same? So because all the denominators are the same, we can now solve this by just looking at the numerator, the top. So we are going to now just combine like terms and solve for x. So we have 5x is equal to 60. Divide by x, 5, correct? So x is equal to 12. Does everybody see how I did that? All right, now we would check our solution. So we go back to the original, plug it in. So we have 12 over 3, and honestly, checking it tends to be the hardest. 12 over 3 plus 12 over 2, does that truly equal 10? We're plugging it back into the original. Yes, it does. We're all good? No questions. Okay, let's do another one. Number 2. So we need a least common denominator. This is 0 over 1 technically. So we have an x in this one and a 9 in this one. So our least common denominator is 9x. Let's make all of the denominators 9x. We multiply by 9 over 9. We'll multiply by x over x. And we'll multiply by 9x over 9x. So now we have 9 minus x squared, correct? I shouldn't have skipped. I'm going to do 9 over 9 minus x squared over 9 is equal to 0. Isn't 0 times 9x 0? Over 9x. Now look at all the bottoms. Aren't they the same? So now we can just focus on the top and solve. So we have 9 minus x squared is equal to 0. Solve for x either by factoring or algebraically. I'm going to algebraically solve. That's easier. What would I do? Oh, I like that idea. There's 2 ways. I like that idea, actually. Let's add x squared. So we have 9 is equal to x squared. So So now square root it, right? Good. I'm glad that you remembered it's plus and minus 3. So we get x equals positive 3, x equals negative 3. So we'll plug that back into the original. So we have 1 over positive 3. I'm checking x equals 3. 1 over 3 minus 3 over 9. Does that equal 0? 1/3 minus 1/3, right? So that one works. We get to keep it. And then we'll check x equals negative 3. So we have 1 divided by negative 3 minus negative 3 over 9. Does that equal 0? Yes. Yeah. So we'll keep it. Questions? Okay, last one. Now, if I would have given this to you before you learned this lesson, you should have been able to do it. Can anyone tell me how you would go about solving this before you learned this lesson? Give it a try. I mean, what's the worst? You could be wrong. That's the worst thing. Yeah. That's a good idea. That's what we learned today, was getting a common denominator. What's the way you would have done it? Yeah, cross multiplication, which is essentially, the math behind it is getting a common denominator. We're essentially, when we cross multiply, getting a common denominator. Does that make sense, everybody? We can just cross multiply, but that's just doing the same thing as getting a common denominator, right? We would multiply this side by 3x plus 1, right? And then this side also by 3x plus 1 technically, but doesn't it divide out? So do you see where cross multiplication comes from? We multiply both sides by 3x plus 1. Don't those divide out? So we have over here negative 4 times 3x plus 1. Oh no, it started doing that thing again. Oh yeah. Okay, so then we have this x plus 1. So aren't I going to multiply technically both sides by x plus 1? So don't those divide out? So we have it's equal to, and we've got to put parentheses here, so that's 5 times x plus 1. And now we can distribute. So negative 4 times 3x is negative 12x. Negative 4 times, I can't even read what that is because it went crazy, 1. So that's minus 4 is equal to 5x plus 5, right? It's been like my pen's been like connecting all my stuff today. So now getting the x's alone or together when we add 12x. So we have negative 4 is equal to 17 x's. Then we have plus 5. So we subtract 5, right? Negative 9 is equal to 17x. Divide by 17. So x is equal to negative 9 over 17. Then we've got to check it. You really do have to check it. So we have, now the hardest part is typing it in correctly. So everybody, let's practice this. We have negative 4 divided by, now we've got to actually calculate the bottom first before we divide the negative 4. So that's negative 9 over 17 plus 1. You got to calculate this piece first and then do 4 divided by that. And then we would do this, 3 times negative 9 over 17. I don't know why it's connecting my stuff together. So calculate that. See if you get those statements to be true. So when I typed it in, if you typed this side incorrectly, you should have got negative 8.5. Did we get that? If you typed this side incorrectly, you should get negative 8.5. So that's a true statement. So we got to keep the solution. It's not extraneous. None of these have been extraneous so far because we've only had to do very basic simplifying here. So that's why we haven't run into any extraneous solutions. You ready to practice? Okay, do 4 through 9. Doing some really weird things last hour. I didn't pay attention to this. We want a least common denominator because otherwise we're going to have a lot of simplification and we don't want that. So the first thing you need to do is factor out the bottoms so that we can get the true least common denominator. Does everybody understand? So this is really 2 over x plus 3 plus 5 over negative x plus 3, right? Now we could factor out that negative and have x minus 3. Now we could either have negative 1 in the denominator as the least common denominator, or isn't it the same thing as putting a negative 1 on top? The negative can either be with top or bottom, doesn't matter, right? But not both. So I'm going to just put that and I'm going to change my mind and say, okay, I'm doing 2 over x plus 3, and then I'm going to bring that negative 1 on top. Negative 1 times 5 is negative 5. And now I'm just dealing with x minus 3. Does that make sense, everybody? And that's equal to 6 over, factor the quadratic, it's the difference of 2 perfect squares. So x minus 3, x plus 3. Conjugates will make the middle term cancel out, right? Okay, now let's get a common denominator. It's x minus 3, x plus 3. So let's fix it. We're going to multiply by x minus 3 over x minus 3. We always put parentheses, x plus 3 over x plus 3. Now our denominator is the same. So now we can go ahead and just ignore those and focus on solving the top. So that's 2x minus 6. See how it's like connecting? Why is it doing that? Oh, well, I've never done that before, but you're right, that's what it is. Okay, but we'll continue. So then we have minus 5. I'm lifting up my pen. That is so annoying. Okay, minus 5x. Now here's where a lot of people would mess up. That's negative 5 times positive 3, right? So minus 15 is equal to, we didn't need to change that, 6. Does everybody feel good? So now we combine like terms. That's negative 3x. It's like in this section the smartboard's having in the school. Negative, I'm so mad. Negative 3x. And then we would subtract 6, add 15, right? Wait, is that a minus 6? I can't even remember. So we have minus 6, minus 15. So let's add 6, add 15. Is everybody good with that? Add 6, add 15, add 15. So now we have 3x is equal to negative or positive 27. You combine those, that's 27. So we'll divide both sides by negative 3. So x is equal to negative 9. Everybody feel good? Okay. We would check it though. We would absolutely check it, but I'm not going to take the time to do that right now. It does work. Do number 10 and check your answer. Or answers. Then you would check it and it does work. Okay. Do you feel like you need another one like that? Or do you feel good with those? We'll move on. Do you want one more like that? Do you want to do, yeah, let's have you do this one. Here you go. Actually, let's do this one. I like this one better. It's a little bit more advanced. Go for that one. So check up here in my work, just seeing if you got this far. So I factored the bottoms, rewriting that with the negative in standard form, factoring out the negative. So we're up to here. I put that negative 1 on top right up here so that I don't have to have a least common denominator with a negative. So we're able to get this far. And now we fixed the denominator, so I'll let you see if you can finish this one. How many of you were able to get up to the quadratic of this? A lot of you were. That's what you should have. Then we would solve the quadratic by factoring. Multiplies to be negative 6 and adds up to be negative 1. 3 times 2, negative 3, positive 2. Then we have to drop and break. You quick factor and you're a wrongo. So when you solve by factoring, you should have factors 3x plus 2 and then x minus 1. And then you'll set each of those equal to 0 and solve. You should get x is equal to negative 2/3. And you should get x is equal to 1. But you've got to check. So everybody, this worksheet, and these examples, none of them came out extraneous. I plugged in both of those back into the original and they came out. But that was a bad mistake on my part. I should have done some examples where there were extraneous solutions because you are going to run into those on the homework and on the test. But you guys understand, right, that if I, let's say, so listen, if I tested negative 2/3 and did not get a true statement in the beginning, then I would just throw that answer out and the only solution would be 1. Now, if you were to test both and neither of them worked, you would say no solution. That means there is no value for x that will make that statement true. Does that make sense? Because there are times when you'll throw out both answers. I don't know how that happened, but none of my examples had extraneous solutions, but trust me, there will be. Yeah. Okay. Sweet. Okay, now I'm going to show you a fun thing to use in case you want to check your answers. So we can also solve by graphing on our graphing calculator as well, but only if, so algebraically is really my favorite and honestly the best because then you know for a fact you're getting them right. But graphing has its advantages. Now we would only ever use solving by graphing to check our answers, and that would only be to check if we have whole number solutions. So guys, think about it. What is this saying? When does this function equal this function? So can't we just graph this function in y1, graph this function in y2, and see when they're equal? Which would be where they intersect, correct? So let's do that. So we're doing problem number 13. So you'll type in parentheses. It's all about typing it in right. So you'll do your x minus 1. I'd put it in parentheses just to be safe. Divided by 6. And if you ever have two things on bottom, you've got to use parentheses on bottom. And then we're doing x over 4. So these are just two different functions. We want to know when do those equal each other. So we could do this algebraically like we just did a second ago, or we could just graph it. Now their lines, we can see where they intersect somewhere right here, correct? Looking like somewhere right there. So we'll do second trace, go to intersect. And it says first curve is on the first line, so we're good. Second curve is on the second line, so we're good. Enter, we do want you to guess. So x equals negative 2 was the solution. Everybody understand? So if we would have solved it algebraically, we would have got the same thing. X is equal to negative 2. So you can solve these by graphing. Now understand one thing. Your window, like let's say you graphed two functions and it says error. Even if there's no solution, that just means that the graphs will never intersect. Does that make sense? So you'd look at it and they would be like parallel or something. Does that make sense? They would never intersect. That would be no solution. Keep in mind if your window isn't, yeah, they're definitely going to intersect, but I can't see it in my window. That's when it will say error. So you'd have to change your window to be able to actually see the intersection. Does that make sense, everybody? Okay, I'm going to give you a second. Do 13 through 21 by solving by graphing. Now, if you get to one that you're like, the graph looks terrible, the calculator is only to help you make it easier. So if you ever want to go back and just do it algebraically, I'm never against that. Does that make sense, everybody? So there's one I graphed, and I was like, I can't tell what the heck's going on. I'm just going to do it algebraically. I got to plug in my thing. So stop doing those. Stop doing those. That's good enough. Number 28. Here we go. This one is actually one you could see on an ACT for sure. Like I have seen ones very similar. And so here we go. There's one on the homework like this. You're going to want to watch. So it says one delivery driver can complete a route in 6 hours. So our first delivery driver can complete a route in 6 hours. One route. Okay. Then our second delivery driver can complete that same route in 5 hours, correct? Okay, so he's obviously faster than this person. It says, let n be the total number of deliveries on the route. Write an expression to represent the number of deliveries each driver can make in an hour. So if they're making n deliveries in 1 hour, wouldn't it be n out of 6? Will be 1, correct? That's how many we make per hour. Does that make sense, everybody? And so this dude can do the same. We're using n again because it's the same number of deliveries. Or no, it's not the same number of deliveries. Sorry, n over 5 is going to be how many he can make in 1 hour. Does that make sense? Okay, so we've done A. Now let's answer B. It says write an expression to represent the number of hours needed to make n deliveries if the drivers work together. So now if you think about it, instead of this person being able to do n over 6 and this person doing n over 5, wouldn't it be them together adding them? Yeah. So n over 6 plus n over 5 equals 1. Now we'll solve for n. Just getting a common denominator. Common denominator is 30. So let's make each of the denominators 30. So we'll multiply by 5 over 5, 6 over 6, 30 over 30. So that's now our denominators are the same. So we can just focus on solving the top. So we have 11 n's equals 30. So now you'll divide both sides by 11. And you get n is equal to 2.72 hours. Now this answer would not be considered correct on an ACT. You would get it wrong because they would say 2.72 minutes, 2 hours and 72 minutes, which would be wrong. How would we do this? Okay, I want you to think of this. Isn't 0.72 saying 72%? Yeah, that's what 0.72 means. So we want 72% of an hour. So how many minutes is that? 60 times 0.72. If I want to know, you get why. How many? Okay, 43 minutes. So this is 2 hours and 43 minutes. That's how, you guys, that's how much they can get done together. How quick? Is everybody feeling good about that? Instead of getting it done in 5 hours by himself and the other one 6, together they get it done in 2 hours and 43 minutes. So wouldn't you rather work together? Yeah. Everybody feeling good? Okay, I want you to do this one, 29. Do 29, same idea. Everybody back up here. So hopefully you were able to get, that was 2 hours and 16 minutes. Okay, and you guys got 12 seconds, I'll go for it. Okay. Okay guys, everybody up here, this is honestly the hardest part for students because people at this level make a lot of algebra mistakes. Remember how I told you people fail calculus for algebra? Literally, my calculus teacher would say to me, there are right ways to solving these and there are long ways. And that's just because we had to go through lots of algebra in calculus. So this is really good practice for calculus because you have to know your algebra. You have to not break any forbidden rules. So these are what are called literal equations, and you will see these on ACTs. A literal equation just means given an equation, solve for any variable I tell you to solve for. So couldn't we use algebra and solve for B? Couldn't we use algebra and solve for A? Okay, so that's just what it's doing. So let's do number 22. Let's use the correct, you have to use correct algebra. Now you might go about simplifying this, solving this different than me. As long as your algebra is correct and my algebra is correct, our final answer will be the same. Does everybody understand? But there are right ways and there are long ways. So you might want to do the easiest way. So everybody look at this one. We have h is equal to 2a. I'm just rewriting it over b. It says solve for b. That colon b means solve for b. Do you all understand that? So try to get b alone. Let's do this the easy way. What would be your first step? If we multiply by 2a, that becomes 4a squared, which would be worse. Multiply by b. So we have bh is equal to... No, and that was actually is equal to 2a. And you know what? That was actually what a lot of people do. So that was a good point. So solving for b, next step. How do you undo multiplication? And now isn't b alone. We've solved. Okay, let's do a little bit harder of one. Looking at this, there's a couple different ways we can tackle this problem. And half the time I change my mind and do it differently. Yes. It's just di. Like, that's just a variable. Just, that could be a heart. And chocolate cakes. Like, those are just variables. It's not an I like density. Hey, guys, come on, up here. So let's solve for d naught. Now that d sub 0, these are just variables. So we're trying to get d sub 0 alone. Make sure you don't make the tragic mistake. Listen. I say I'm going to multiply by d naught. No, you can't just multiply a piece of a side by something. Do you all understand that? That's what I saw most commonly in last hour. So our first step would be to do what? Subtract that, right? So we have 1 over f minus 1 over di, that's just a variable, is equal to 1 over d naught. Does everybody see that? So over here we would probably, well, we would need to get a common denominator. There's a few different ways we could do this. That's the thing. Let's get a common denominator. Does everybody agree? So we multiply by di over di. We would multiply by f over f. So we have now common denominators. So we have di minus f on top, and on bottom we have di times f, correct? And that's equal to 1 over d naught. Now we could cross multiply, correct? So I'm going to multiply by d naught, put that in parentheses, and I'm going to multipy by dif. Now I had somebody last hour say, can I get a common denominator? Yeah, that's what we just did. We just, you know what I mean? That is what cross multiplication is. Yep, that's what we're doing. Because wouldn't the d naughts cross out over, wouldn't our bottoms now go away? We have a common denominator. Does everybody understand? Okay, now so we have d naught times di minus f equals dif. What's my last step to get d naught alone? Divide by di minus f. Very good. Divide by di minus f. Now, can anything simplify there? No. That's a subtraction sign, right? So we're done. D naught equals that. Does everybody see how there could be a lot of room for error on algebra? Okay. Okay. Everybody look up here. Let's do this one. So it says solve for C. There are right ways and there are harder ways. We could get a common denominator, but that's going to become nightmarish. I'm going to bring this over this way. Does everybody feel good about that? So I'm going to add C over A squared minus B to both sides. Sorry. So then we have over here, 1 over C is equal to C over A squared minus B squared. Now to get C alone, what would you do? Cross multiplication? Yeah, I like that. So let's multiply by A squared minus B squared and C, correct? So we have A squared minus B squared is equal to C squared. Last step. Square root both sides. So we have C is equal to, we can't forget when we're solving, we have a plus and minus, the square root of A squared minus B squared. I'm going to ask you a question, answer it very carefully. Would it be okay to just say root, cancel out those powers? No, because we know this is truly not A squared, this is truly, technically, A minus B times A plus B, right? So that would be just square rooting that, which we know is breaking the forbidden rule, right? So we would leave our answer like that. Or this would also be acceptable as an answer, because it's the same thing. C equals, does everybody see? Okay, solve for B, then I'm going to let you practice a few. So solve for B, what would you do? Okay, I heard somebody say multiply by B squared R squared, which is fine. You're just going to do an extra algebra step in the end, which is fine. What would be, I would personally, are we trying to get B alone? So I don't need to bring R squared over. I'm only going to bring B squared over. Does this make sense? So I'm going to multiply by B squared over B squared. So look, our B squareds cancel out. So now I have B squared Q over M, correct? Equals, and then we have 2B over R squared. Remember, our goal is to get B squared alone. So now I'm going to multiply by M. So M and M, those divide out. So we have B squared Q is equal to 2BMs over R squared. Last, almost there, divide by Q. Actually, I'm going to be smart about my algebra. Do I want to divide by fractions? No. So isn't this okay to multiply by 1 over Q? Q over Q. So we have B squared is equal to 2BM over R squared Q. Square root it? Okay. So we would have B is equal to plus and minus the square root of all that stuff, 2BM over R squared Q. Square root it. Everybody feel good? Okay, literal equations. Do 24, 25. If you on 24 first want to multiply by t, you will be wrong. Don't do that. On this one, I would personally multiply this x2 minus x1 up. Okay. Everybody there. Now we're solving for, remember what's our goal, solving for x1? So I would divide by, well, there's a couple different ways you could do this. You could divide by m. Who divided by m next? Okay, interesting. Who distributed the m through? Interesting. I actually the first time distributed m through. I'm going to not this time just to see where it goes. Either way, we're using the correct algebra. So I'm going to divide by m just for fun. So we have x2 minus x1 is equal to y2 minus y1 over m. Now you might get the same answer. The first time I did it, I got a little bit different form of the correct answer. Last step to get x1 alone. Nope, 2 more steps. When we subtract x2, right? So we have negative x1 is equal to, that's where some of you that had a sign error, like he was only off by 1 sign, and that's because there was a negative here he might have forgot about. y2 minus y1 all over m, and then minus x2. So then we would divide, we would multiply both sides by -1, correct? So we have x is equal to, this becomes a negative, that becomes a positive. Negative y2 plus y1 over m, and then plus x2. Now the first time I did it, I distributed the m through, which was fine, and I got the answer. x1, that's an x1, equals negative y2 plus y1 plus mx2 all over m. Now look at, they are the exact same answer, guys. They're just written in different forms. They split it up, but they kept both divided by m. You see how the m's divided out with the x2? It's correct. Both are correct. They're the exact same thing, guys. Hopefully you're able to see it. You see it? Okay. Go ahead and try these ones. You can do it. You can do it. Let me show you an easier one, for example. Everybody look. If I have 2x plus y, x equals z, and I said you solve for x. What you should do is say I have an x in common. So left is 2x plus y. You see how now I only have one x? Okay. And then you would have had one last step. That's about the level we get in regular secondary 3. So looking up here, we would say, okay, we're solving for x. Now notice we have 2 x's in common, right? So we would factor out an x. So then left would be y over z plus 2. And that's equal to z over y. Now careful, because your algebra's got to come out correct. We could right here divide by y over z plus 2, right? But then you're going to be dealing with complex fractions, which is fine. So now you can't flip a second and multiply, right? Because isn't this need to be simplified before you can do that? Okay, so now you can continue to simplify by getting a common denominator. So we have z over y divided by, our common denominator is z. So we would have y plus 2z over z. Now dividing fractions easy as pie, flip the second fraction, so z comes on top, and you multiply. So y plus 2z. Now you would say, do anything simplify out? Nope. So we have x is equal to, we multiply straight across, we get a z squared, and on bottom we have y, we don't have to distribute that bottom through, y, and then y plus 2z, as long as we use parentheses. Yeah. Yes. Okay. Yeah. I think it does accept quite a few. And if not, it'll say your answer can, as long as it can be, like, you can't, if you're dividing by fractions and type that in, it would expect you to be able to simplify that. You know what I mean? Yeah. In the correct form. So then look and say, how could this possibly simplify? Yeah. Okay, try to get 27, yo. Try to get 27.